Good, good morning, class. How you doing? So today we're gonna talk a little bit about writing a linear function from word problems. So as you can see, the objective here says to write a linear function from a word problem. So make sure you go ahead and take the time to copy the objective down. Okay. So let's move here to operational words. All right, so operational words, these are some of the words that we have been familiar with and you guys should be familiar with. So if you are not really familiar with these words, you should take the time to go over some of these, make sure that you're familiar with them because these are going to help us to write our operation words. All right, so for us to write a linear function from a word problem, there are certain steps that we have to take. As you can see here, first thing that we got to do is you have to read it. You cannot solve it if you don't read it. All right, so you have to read the problem first. Then you have to identify the input, your output. You have to and you have to also identify your y-intercept, and this is also known as your starting point. All right, the input directly affects the output, and your y-intercept, as I said earlier, is your starting point. And one of the most important things you gotta be mindful of is slope intercept form. This is how we're gonna write, all right? So y equals mx plus b, where m is your slope and b is your y-intercept or your starting point. And you can use this to create your equation. So with that being said, we're gonna go ahead and we're gonna transition to the first problem, all right? So I'm gonna turn to my document camera here. And as you can see, I already have the problem loaded and we're ready to go. So if we read this first problem, it says that Bren prepares 8 kilograms of dough every hour he works. And this word every here is important because this word, it tells us about our slope. All right, so this is going to be very important, the word every. He works at a bakery. Write the equation that shows the relation between the hours worked, X, and the dough prepared, Y. So we read it. In order for us to create an equation, let's look at what we have. We have Y is equals to MX plus B. All right. But here we do not have a starting point. All right. So I can rewrite this by saying Y is equals, and here if we look at this, if X represents the number of hours worked, right? And Y represents the amount of dough prepared, right? Y represent the amount of dough prepared and X represent the number of hours. He can make 8 kilograms of dough for every hour he works. We don't know how many hours he's gonna work, so we're gonna call that X. All right. So here Y equals 8X is gonna be my function. So let's just say, what if he worked 1 hour, right? If he worked 1 hour, we're gonna substitute 1 for X. If he worked 1 hour, right? We're gonna substitute 1 for X. So Y would be what? 8 times 1. So in 1 hour, he would make 8 kilograms. If it was 2 hours, right? We're gonna do the same thing, substitute the 2 for it. So Y is equals to 8 times 2. So we would know that in 2 hours, right? He would have produced how many? 16 ounces. 16 ounces of dough, and it goes on and on. All right. So let's go to the second problem. But here, our equation would be Y is equals to 8X. All right. So let's look at the second problem. Example 2. All right. So example 2 here says Eva has already baked 4 cakes and she can bake 1 cake with each additional egg she buys. All right, so she's already made 4, and for every additional egg she buys, she can make an extra one. Write the equation that shows the relation between the number of additional eggs, X, and the number of cakes, Y. So again, we start off with our equation. Y is equals to mx plus b. What do we know? We know that she already started with what? 4. So the 4 here, 4 cakes becomes my starting point. Or as we know, this is my y-intercept. So I can go y is equals to blank plus 4. All right. So what do we know? We know that for every she can bake what? One cake with each additional egg. We don't know how many eggs she's gonna buy, so we can say one cake for x eggs. All right. So let's look at this. What if, and my equation will be y is equals to 1x plus 4, or as you guys know, this is the same thing as y is equals to x plus 4. This is understood. Your coefficient for x is an understood one. It's an imaginary one. So please take note of that. So let's look at an example here. What if we had y is equals to, let's say she bought one egg, right? So it's going to be 1 times 1 plus 4. So one egg, she already made 4. And with one egg, she's going to make an additional one. So that means she'll have 5 eggs. If she bought 2 eggs, it will be y is equals to 1 times 2 plus 4. So she already did 2. She already did 4. And then 2 is going to give me what? 2. All right. So that will give me 6 cakes. All right. And it goes on and on and on. All right. Good. So let's look at our last example. Let's look at example 3 right here. All right. So on example 3, Leroy says he's watched 20 seconds behind, 20 seconds behind. All right. The 20 seconds is going to represent my starting point. All right. Remember again, my starting point is my y-intercept. And it says it falls behind an additional 3 seconds for every. Here's that word again, that every. And that means that's going to represent my slope. All right. Write an equation that shows the relationship between the days that the watch lasts, x and y. So again, we start off with y is equals to mx plus b. We already know what b is because it's y equals to blank, all right, plus 20 seconds because it's already 20 seconds behind. So we start in 20 seconds behind. And the every comes back here, it says 3 seconds every day. So 3 seconds every day. How many days is it? We don't know how many days it's going to be. So now it's y is equals to 3x plus 20. That's my equation there. And as we can see, we can say, what if he said, all right, 1? What if it was 1 additional day? All right, 1 day behind. So each day is going to be 3. So it's 3 times 1 day plus the 20 seconds behind already. So that makes it 23 seconds behind. So that'll be 23 seconds behind. And I could do the same thing. What if it was 2 days? Y is equals to 3 seconds for every day, but it's 2 days plus 20. So y would be equals to 26 seconds behind. All right. So that's all it is. And this goes on and on and on. So please, if you need help, just reach out to myself or one of the other teachers and we can help you. All right. Thank you. Bye.